CERN exploded the world in 2008. It's been anticipated over and again that CERN will clear off the universe and its occupant. And it appears as though this expectation is all approaching genuine like never before thanks to the unusual examinations directed by the enormous Hadron Collider. Leading researchers at CERN have distinguished another molecule that can possibly change everything. In his Joe Rogan Experience webcast, Joe Rogan said that a portion of the uncommon events happening universally may be connected to these perilous preliminaries. Isn't it odd that these huge revelations are being concealed by the traditional press? Despite the fact that this disclosure can possibly be more prominent than life itself and perhaps the greatest discovery made by humans to date, there's an explanation they are concealing this critical disclosure. What might they at any point have found at CERN if something somehow happened to turn out badly? What might be the outcomes of that incident? Join us as we explore the mystery surrounding the huge Hadron Collider as Joe Rogan makes a chilling announcement. Various confounding events at the European Association for Nuclear Research in the beyond couple of months have aroused the curiosity and concern of both scientists and the general public. The exact nature of these events is unknown, but they highlight how complicated and mysterious particle physics is, and how much more research is needed in this area. Although CERN primarily focuses on the universe's most fundamental particles and the principles of physics, it has also produced other significant scientific breakthroughs. For example, the idea of a distributed information system was advanced by physicist Tim Berners-Lee in 1989. That system evolved into what we call the World Wide Web. Indeed, the world's first web page was created at CERN, further expanding our understanding of the universe. Advancing our comprehension of the universe is the primary goal of most CERN research. Countless scientists do experiments solely for the purpose of understanding the workings of natural laws, completely disregarding any notion of practicality. Scientists sometimes call this pure research. 20-part states from Europe currently run CERN. Both the responsibility of supporting CERN and the coordination of activities at CERN facilities are shared by these countries. Additionally, CERN has global associations that allow other countries to use its labs for research and experimentation. Could CERN ever truly bring an end to life as we know it? And how could a single institution use a contraption like the enormous Hadron Collider to solve complex worldwide mysteries? Throughout the history of particle physics, CERN has consistently been at the vanguard of significant discoveries. Yet we are currently dealing with something different. Particle acceleration tests have shown unexpected inconsistencies and unexplained data changes over the last year. A baffling revelation revolves around the LHC's signals, which have sometimes captured strange particle signatures and energy levels never seen before. These disparities seem to contradict the established rules of particle physics, making them all the more puzzling. Scientists have been meticulously reviewing and reanalyzing their data, but they still haven't found what's causing these anomalies. Additionally, some peculiarities in the LHC's surrounding magnetic field have prompted speculation regarding possible environmental causes. CERN's underground facilities have always operated in proximity to one another due to their deliberate design to minimize external interference. Curious about the origin of these disturbances, however, researchers have noted seismic events, variations in Earth's magnetic field, and unexplained changes in the LHC's magnetic shielding. One theory is that this particle could be a larger, heavier version of the Higgs Boson, or the God particle. If this is true, it could lead to a complete rethinking of our understanding of the universe and its operations, as well as the opening of doors to other dimensions. But would this be a good thing? If the story is true to its core, this particle would be multiple times heavier than the heaviest known particles, the top quarks, and up to multiple times larger than the Higgs boson, a God particle, a theoretical possibility initially proposed during the 1960s. Second, and most intriguingly, the spikes could be evidence of a newly discovered theoretical particle called the SOS intercedes all gravitational force. Some prominent scientists believe this particle could open the door to other dimensions in the universe. But with what outcome? Others have even gone so far as to say that it's all a complex lie and that they've actually discovered new universes. They're just slowly letting us in on the secret. The latest finding followed the discovery by scientists at CERN of startling spikes in photon particles in the data from 2 LHC detectors. Allegedly, spikes reached 750 giga-electron volts, which are believed to have been generated by massive high-energy proton collisions. French scientist Adam Falkowski started the speculation after tweeting about the significance of the spikes. This massive discovery could make modifications to the standard model of the universe's interactions. Clearly, this has the potential to alter our entire understanding of the universe and everything in it. Adam Falkowski posits that this particle is likely to be a minor part of a larger picture, perhaps linked to electroweak symmetry breaking and the standard model's dark matter. Another golden age in particle physics may be on the horizon if the signal turns out to be authentic. A paradigm shift would occur if the findings truly describe a clever particle. In terms of creativity, the Higgs boson is completely overshadowed. How exactly does the enormous Hadron impact potential, and what is its true purpose? The Large Hadron Collider can recreate similar conditions from the early universe. While some see it as the key to understanding the universe, others fear it could endanger Earth's biosphere. The LHC structures the core of a vast accelerator complex near Geneva. It releases immense energy by shooting protons and particles into beams that are almost as fast as light. The LHC carefully records the particle showers produced by these massive collisions, with the hope that a better understanding of the universe's structure and how everything came to be can be gleaned from these brief moments. Although the LHC may not be immediately practical, its contribution to greater understanding makes it worthwhile for both the thousands of scientists from around the world who collaborate and compete. The Higgs boson particle was one of many mysteries of the universe that the Large Hadron Collider has helped to uncover. A theory known as the Standard Model was advanced by scientists in an attempt to understand the structure, operation, and workings of our universe. The basic building blocks of the universe are a puzzle to be defined and figured out by this theory. It addresses three of the four major forces known to man: the electromagnetic force, the weak nuclear force, and the strong nuclear force. By combining ideas from quantum theory with Einstein's theory of relativity, gravity is the fourth fundamental force. Although it does not govern its effects, various predictions regarding the universe have been put forward by the Standard Model. In 2012, the existence of the Higgs boson particle was confirmed thanks to the LHC, which was one of its key predictions. To understand why certain subatomic particles are heavy, we need to look no further than the Higgs boson. The Higgs mechanism proposes a particle and a corresponding force that gives other particles mass, whether neutrinos and some other particles have any. The discovery has prompted scientists to continue exploring the LHC for more information and novel ideas. The early stage of the universe is the subject of another matter-related mystery to scientists. The universe began with matter and energy interacting, with particles of matter and antimatter annihilating each other. Immediately following the separation of energy and matter, both matter and antimatter would have balanced each other if their quantities had been equal. The universe included some antimatter, but fortunately, there was also some matter. Scientists hope that they'll be able to observe antimatter during LHC events, which could help us understand the reason why there was a slight difference in how much matter versus antimatter when the universe began. Research on dark matter is another area that the LHC is focusing on. Based on what we know, currently observable matter accounts for around 4% of the total mass of the universe. A significant amount of invisible material known as dark matter, which makes up about 25% of the universe, is revealed by the motion of galaxies. Dark energy, the so-called driver of the expansion of the universe, is thought to account for the rest. More experiments at the LHC, according to scientists, should reveal more about these mysterious aspects of the universe. By smashing protons together forcefully enough, the LHC makes protons break apart into smaller nuclear subparticles. These tiny subparticles are extremely unstable and only exist for a fraction of a second before decaying or recombining with other subparticles. However, these tiny subparticles made up all matter in the early universe, as proposed by the Big Bang theory. Larger particles, such as protons and neutrons, were formed when these smaller ones combined during the expansion and cooling of the universe. Some scientists believe the LHC could discover evidence of additional dimensions. If the unexpectedness of hypothetical particles, antimatter, and dark energy isn't enough, we're used to living in a universe of 4 dimensions, 3 spatial dimensions and time. However, there are physicists who have proposed the possibility of other hidden dimensions. A complex universe is necessary for the credibility of certain theories. One detailing string theory mentions the existence of 11 dimensions. Those who believe in string theory are hoping that the results from the LHC will lend credence to their infinite model. String theory states that the fundamental building block of the universe is not a particle but a string. There are two types of strings, open and closed. They can vibrate as well, just like the strings of a guitar do when played. The strings seem to be different things when vibrated in different ways. An electron would seem like a one-dimensional string vibrating in one direction. A neutrino would be an alternative string vibrating in the opposite direction. There is no evidence to back string theory, according to some experts who have dismissed the theory. One thing that physicists cannot achieve without a unifying theory is to include gravity in the standard model. String theory does just that. It brings the quantum field theory into harmony with general relativity, Einstein's proposition. However, the existence of these strings remains contentious. At present, there is no method to detect them because they are too small to be seen. Because of this, some researchers have discounted string theory as a philosophical concept rather than a scientific one. String theorists are holding out hope that the LHC will convince skeptics. Supersymmetry is something they're trying to detect. The standard model states that for every particle, there exists an antiparticle. A positron is the antiparticle of an electron, which is a negatively charged particle. Particles, according to supersymmetry, also have superpartners who also have corresponding antiparticles. The LHC might confirm the existence of these superpartners, although we haven't found any evidence of them in nature. If superparticles exist, they might shed light on the nature of dark matter and make it easier to include gravity in the current standard model. The basic idea of the LHC isn't complicated at all. To begin, you'll need to direct two beams, one clockwise and one counterclockwise, to launch particle beams. The two beams are accelerated rapidly to nearly the speed of light. You can then observe the results by pointing the two beams in the direction of one another. The instruments needed to achieve that goal are much more complex. The Large Hadron Collider is just a part of the complete atom smasher complex housed within CERN. Several processes need to be completed before protons or particles can enter the LHC. Scientists face a massive challenge with the 15 petabytes of data collected each year by the LHC detectors. With such data, how can one grasp everything within such a massive dataset? How could one tell if they're analyzing something significant? That much data could take years to process, even on a supercomputer. Meanwhile, the LHC keeps accumulating even more data. CERN's solution to this problem is the LHC computing grid. The grid is a network of computers, each of which can analyze a chunk of data on its own. Once a computer finishes its analysis, it can send the findings to a centralized computer and accept another chunk of data. The method is effective so long as scientists can segment the data. Grid computing is the term used to describe this method in the computer industry. The scientists at CERN have opted to use low-cost hardware to implement their calculations. Commercially available, network-ready equipment is CERN's primary focus, rather than cutting-edge custom data servers and computers. The LHC enables scientists to view particle collisions at an incredibly high energy level, surpassing any previous experiment. Some are concerned that the planet could be in for some serious disaster due to such massive reactions. Some were even sufficiently worried to sue CERN in an attempt to postpone the LHC's activation until later. In what ways will CERN shape the universe in the years to come? Recognizing the project's advantages and disadvantages will help us delve into CERN's mission and the reasons some are worried about the organization's actions. According to how we perceive the universe, the matter we can observe only accounts for about 4% of all the matter that exists. Physicists have proposed a type of substance called dark matter that could make up to 25% of the matter in the universe. When combined with what we can see, the other 75% could come from dark energy. Some scientists at CERN believe the LHC will uncover evidence of dark matter. Moreover, black holes could be created by the LHC. Singularities are points of infinite density that matter is compressed into by a black hole. Compressing matter so much is generally thought to be harmful. Some are concerned that the black holes created by CERN could crash the planet. According to experts at CERN, any black holes produced by the LHC will be very tiny, harmless, and evaporate almost instantly. CERN may discover a hypothetical particle. One of the big mysteries of the universe deals with mass. Why is there mass? What determines whether a particle has mass? A theory called the Higgs mechanism suggests that there may be an unseen particle that could figure out mass. Controlled collisions within the LHC could produce evidence of this particle. Strangelets, a potentially dangerous substance, may be produced on Earth by CERN. Strangelets are entirely speculative, just like the Higgs boson. However, strangelets are very undesirable customers, unlike Higgs particles. Some claim that this substance can break down and reassemble any substance it comes into contact with, resulting in an unpredictable substance. Strangelets have never been found in nature, according to sea specialists, and even if they were, they would dissipate before causing any problems. Whether they time travel is just one of many complex real-world possibilities that could arise from our expanding knowledge of the universe. According to some physicists, the LHC has the potential to become the first time machine on the planet. They claim that traveling back into the past could only be feasible up until the time machine was first invented. However, these theories failed to convince other scientists. If our understanding of the universe continues to expand, a future supervillain might gain access to knowledge that could endanger humanity. To be fair, the fact that CERN isn't located near a city makes this scenario highly unlikely. The fact that the LHC will generate the most energetic particle collisions ever seen on Earth, along with concerns about radiation, are additional reasons for concern. The LHC is 328 feet below ground and has extensive shielding, according to CERN, so it is completely safe to use. Additionally, no one is to be present underground while tests are in progress. Regarding the possibility of collisions, experts note that high-energy cosmic ray collisions occur naturally quite frequently. Interactions between rays and the Sun, Moon, and other planets occur. However, none of these celestial bodies appear to be in danger at present. The Large Hadron Collider will allow for the controlled impact of such particles. Beyond that, there is really no distinction. Ultimately, it seems like CERN has everything handled. The world is still standing after their experiments, which mirror real-world scenarios. The only difference is the strict control and observation of laboratory conditions. One way or the other, CERN's activities could have a significant impact on us here on Earth, but the rest of the universe is likely to keep expanding.